Okay, here's the ideal gas law again. You've seen it before, and how do we use it? So I have an example problem here. If I have 4 moles of a gas at a pressure of 5.6 atm and a volume of 12 liters, what is the temperature? So in order to solve this, there are 5 variables. We're looking for temperature, so we need to know 4 variables. And the question is, do we? So just like when we used to solve like the density problems and stuff, you want to list all of your variables. So P equals V equals N equals R equals and T equals little n. And let's fill in what we know. Pressure, 5.6 atm. Atm is a unit called atmospheres. Has to do with atmospheric pressure. Anyhow, 5.6 atmospheres. Volume is 12 liters. N is 4 moles of a gas. That's, remember, N is the number of molecules, and we have 4 moles. R is right there. Remember, that's our constant. R will have different values depending on the units, so this is the R that we will use for today. That will be given to you, so don't worry too much. And the temperature is our question mark. That's what we're looking for. All right, so when we do these, we start with our PV equals nRT. Now I'm going to just zoom in a little bit. Well, actually, I'm just going to slide this up now that we have our values. So the easiest way to do this, since we're solving for temperature, is to get temperature by itself. So we have to get rid of everything that's not temperature. Well, that means that I can get rid of, I want to leave the temperature where it is. I want to leave this. I don't want to move it. So I'm going to get rid of N and R. They're attached to temperature with multiplication, so I'm just going to divide them away on both sides. Divide by N and R. And these both cancel. So I'm now going to rewrite my equation. Temperature is equal to PV over NR. So every time you solve one of these, you do have to move the equation around. You have to kind of edit it. And once you do, all you're going to do are plug in values and do the math. So this part's the easy part. We plug everything in. Plug it in with the units. So we have pressure of 5.6 atmospheres times volume of 12 liters over N, which is 4 moles, and R, which is 0.0821 liters atmospheres over Kelvin moles. All right, and we can start canceling things. We can actually cancel all the units. Look, atmospheres and atmospheres cancel, liters and liters cancel, moles and moles cancel, and we can see that we're left with 1 over Kelvin, but it's there. So the units are going to be the Kelvin. And if you remember, Kelvin was our units for temperature that we're going to use. Anyhow, now all we would do is type this in, 5.6 times 12 divided by 4, and then divided by 0.821, and we would get a temperature of 204.63 Kelvin. Okay? So your steps are, list all of your variables, and you should be able to fill in 4 out of the 5 variables. The R will be given to you. Rewrite your equation so that you're solving for the variable that's missing. And then once it's rewritten, plug everything in and do your division. Hopefully that makes sense. We're going to try another one right now. When we do this one, I want you to pause it. Pause it and try it yourself first, and then check the work so that you can see if you're doing this correctly. All right, so let me write it down. If I have an unknown quantity of gas At a pressure of 1.2 atmospheres, a volume of 31 liters, and a temperature of 87 degrees Celsius. How many moles of gas do I have? All right, so let's start off. Pressure, volume, number of molecules, R, and temperature. Let's fill them in. Pressure of 1.2 atmospheres. Volume of 31 liters. Temperature of 87 degrees Celsius. That's going to be an issue. We'll come back to that. Our R value is the 0.0821 liters, atmospheres, Kelvin, moles. Okay, this is our question. We want to know how many molecules, how many particles, how many moles. All the same thing, basically. So, but before we start, you see atmospheres, atmospheres, liters, liters. C and K are not comparable. So we actually, you're going to have to convert a lot between Celsius and Kelvin. So really quick conversion off to the side. If you remember, Kelvin was equal to Celsius plus 273. And so we have to convert 87 degrees Celsius, add the 273 to it, and temperature is actually going to be 360 Kelvin. We do have to do this in Kelvin, so you are going to have to do a quick conversion if needed. Sometimes you will, sometimes you won't. It just all depends. All right, so we're good. We have all of our values except for one. So let's go back here. PV equals nRT. We need to solve it for n this time. So let's get rid of RT for both of them. Gone. And let me rewrite this. N equals pressure volume divided by R temperature. And all we do are plug in our values now. So we have, let's see here, we have pressure is 1.2 atmospheres. Volume is 31 liters. Divided by R, which is 0.0821 liters atmospheres over Kelvin moles. And temperature is 360 Kelvin. All right, let's see how our units will cancel. Atmospheres cancels, liters cancel, Kelvin cancels, and we're left with moles. All right, do the math. 1.2 times 31 divided by 0.0821 divided by 360, and we should get a value of 1.2586 moles. Okay? All right, so for your assignment for this one, I'm going to give you one of these problems. I'm going to have you, hopefully, I want you to try and take a picture of your work and then send it in to me. That's what I would like. But I'm only going to make you do one of them. So hopefully this goes well. So check the assignments for the question. But remember, refer back to this video if you don't remember what to do. All right, thank you.